technology. And today, I'd like to talk about my research, comparison of indicators of location Homophily using Twitter flow graph. Let's start. First, we introduce location Homophily. Location Homophily is a tendency that people live near location from their friends. This is because people are more likely to make relationships with people who interact with. This tendency exists even for online relationships on social media. So online social graph is used for user attribute estimation. For example, here, user X friends is shown. It's like friends living Toyohashi, many friends living Toyohashi. So user X has probably user X living Toyohashi. So but strength of the location Homophily is not uniformly located on the graph. In the previous study, it was reported that if the degree of node is high, which means a user has many followers or followees, friends, the estimation using social graph is more likely to fail. For example, celebrities with many followers are not followed by acquaintances, so their location Homophily is weak. Then, by removing these high degree nodes, the estimation performance improves. So the degree of node becomes an indicator of Homophily. In another previous study, it was reported that the follow ratio, which is the ratio of the number of followees to the number of followers, is an indicator of the location Homophily. The user with many followees tend to be followed by many followers. But when the number of followers of user V is much larger than that of followees, the follow ratio becomes low. The ratio can capture the effect of the numbers without correlations. So follow ratio is also a good indicator of Homophily. And here we have 3 user attributes as the indicator of location Homophily. We have a question. Which one is the best indicator of Homophily? And Twitter is used worldwide and used differently by countries. So are these associations consistent among countries? We then conducted an experiment to find the best indicator of location Homophily. We found following 3 points. First, the follow ratio is more stable value among 10 countries than the number of friends and the number of followers. Second, the follow ratio is robust and negative indicator of the location Homophily. And finally, among 3 user attributes, the ratio of the number of followees to the number of followers is the strongest indicator of location Homophily. Due to time constraints, I will present the second and third points in this presentation. So for the experiment, we use 10 countries Twitter dataset provided in a previous study. So there are datasets for 10 countries. These 10 countries are the top 10 countries with the most Twitter users. Each dataset contains home locations, social graph, and user attributes. Social graph and home locations are a network and they are node labels. Social graph is constructed based on mutual flowing relationships collected in 2019. A user's home location is also assigned using zero-tagged tweets collected in 2019. Each dataset contains more than 100,000 users. The user attributes are the number of friends, the number of followers, and the ratio of them. The flow ratio is calculated by this equation because we consider all users are following themselves. We compare these three attributes to find the best indicator of location homophily. Next, I'd like to explain the experimental method to find the most effective user attribute for capturing the location homophily. We compare the strengths of the location homophily with each user attributes. The strength of location homophily is measured based on the performance of home location estimation using a social graph. When home location is estimated based on the location homophily, the estimated performance reflects its strengths. So if a user has stronger location homophily with friends, the estimation is more likely to be successful. So the experiment proceeds as follows. First, the performance of each user location is evaluated, and next, the location estimation is evaluated after filtering the estimation targets using each user attributes. And then the estimation performances are compared with filtering and without filtering. First, all user locations are estimated. We use an estimation method proposed in the previous study. This method is built on location homophily assumption. So then each user is labeled their estimation label. Yes. And then next, we use two filters that removes the users by a threshold using a user attributes. So high cut filter filters users with attributes values higher than the threshold seed. Low cut filter filters users with attributes and lower than the threshold. So remaining users are evaluated in the next step. To measure the strength of the location homophily of certain set of users, and we evaluate accuracy of filtered users by changing the threshold. For each attribute, we find the threshold value that maximizes the accuracy. Then we regard the maximum accuracy as the strength of the Homophily or the user attribute. So here, the experimental results are shown in here. The first, we compare between the filtered result and the result without filtering. The filter with the number of friends showed improvement in 8 countries. Green one. And the high-cut filter with the number of forwards worked in some countries. The high-cut filter with the flow ratio worked in all 10 countries. So the flow ratio is the strongest indicator of the location Homophily. The number of friends was effective, but the number of followers were not effective in almost countries. So they conducted a correlation analysis between 3 user attributes. So we calculated Spearman's rank correlation coefficient. Then we find that there is no correlation between the number of friends and the flow ratio. This implies that the number of friends and the flow ratio can be used to characterize users. In other words, although a user may follow as many users as they like, the probability of being followed back does not depend on the number of friends. So it's use those characteristics. Next, we split the user's attributes. And what does the number of friends indicate? So one reasonable interpretation is the degree of activity. If a user actively uses Twitter, the user follows often. And our interpretation of the flow ratio is a ratio of non-acquainted friends to acquainted to friends. When a user follows someone, if the followed user knows the user will follow back. So the ratio becomes 1 or less. And I'd like to summarize this presentation. Our research question is, which one is the best indicator of location Homophily? And by the experiment, we found that the flow ratio is shown to be the most effective attribute for capturing the location Homophily. Second question, these associations consistent among countries. We found that the flow ratio is the best negative indicator of location Homophily for all 10 countries. Thank you.
Okay, thank you, Shiori, for the interesting presentation. And are there any questions from the audience for this presentation? if not, I can probably ask some question. There is something that is interest. Can you explain a little bit more about the friends definition in this data set?
Friends?
Yes, I mean, as far as I know, there's no friends in Twitter, so
Okay.
there's only followers. Yeah.
I called friends. Friends means the number of friends means the user follows on the Twitter. So friend means not actually friends.
So it's a mutual following the followers, or
mutual following is used on the estimation phase, and user attributes is calculated differently.
okay. So sorry, I just lost it a little bit. So the friends is
friends is user here. User these friends is A, and this slide is not good. So here, user X has 1, 2, 3, 4, 6 friends. So A and B and C and D and E and F. Because I call here friends means followee.
Okay, so the person that they are following. So okay, so the outgoing arc from okay. So yeah, it's kind of it. Another question about the data. Are the data set all the in this that is used here or geotagged, or
all users on the in this data set post geotagged tweets past 1 year.
Are there any distribution of how often they are tweeting, and how, is that has any effects on the?
They tweets geotag tweets 10 or more for per year for in 2019.
Okay. So I think that's quite clear. So it's the follow ratio now. It's the most prospective indicator of this to estimate this user's location. Okay. So are there any other question from the audience? If not, then I'll say thank you, Shiori. There's a chat.
In the chat.
Sorry. Friends followee.
He's my supervisor.
Okay, so there's a question from Ibu Ayu Purwarianti. That is, do you think that the interaction in social media, it's in it. I'll read it out to you. Do you think that the interaction in social media is not influenced by each country culture, proved by your research? How do you think?
I think it's
probably some culture has a different way of preference of following, or preference of having the geotagged. For example, in the EU, like people are very reluctant to put the geotag.
Their behavior is defined by each country, and because the user the average or the distribution of the number of friends or followers differently in each country, and but so the here this result sensei, hi. This result
Okay.
shows the number of friends followers. The result is improved in some countries, not all countries. So, but flow ratio is good in all countries. So the flow ratio to calculate for the ratio of them, it becomes robust values to characterize them.
Okay. I see. Is this answers the question, Sibuayu?